Okay, let's see how you did on those last three questions. So you should have gotten 3x plus 7, x minus 1, 2x plus 3, x plus 5. I wrote down my factor wrong there. And then 2x plus 3 and x plus 2. Okay, so hopefully those went well. Okay, let's try number 8. 2y squared minus 3y minus 20. So we want to look and see if there's a GCF, which there's not. And so we want to set up our problem. So 2y and y. Now my factors of 20, I have 1 and 20, 2 and 10, 4 and 5. Okay. Now, just like anything else, remember I said, if you're looking for a small b value, you're not going to want to deal with that 20 being multiplied to 2. Okay. So if I did 1 and 20, that's going to get me 40. It's way too big. Okay. If I think about it the opposite way, and 20 and 1, that's still way too big because I'm going to get 20 here. So that one does not work. It's way too big. Okay. And now for the first time, we have 2 more options. Now I'm going to tell you a trick that helps you narrow down your tricks or your options even more. Okay. So when we're looking for a GCF, we're looking to see, can it simplify, right? If I put 2 and 10 in this problem, what would happen on that first binomial? What do both those factors have a commonality of? They have a factor of 2, right? So if I put a 2 in there, there should be a GCF, but there's not a GCF. So could that even be an option? No. Okay. If I switched it around and I put 10 and 2, would that issue still be a problem? Yeah, because technically by that statement, you should have a GCF of 5, which you don't have a GCF of 5. So that can't work either. So what you want to look for is that you cannot have factors of your C value that are also factors of your A value. Okay, again, you cannot have factors of C that also have factors of A, because if that were true, then you should have had a GCF to begin with. Okay, but it's not true. So in reality, we know that if I'm dealing with a 2, I can't put another even number next to it. Or if I'm dealing with 3, I couldn't put a factor of 3 next to it, okay? Because then that means I should have simplified further to begin with. So that means 2 and 10 is eliminated. I can't do it because both the factors are even, and that's not going to work. So now I have 4 and 5. Now, by definition, does that mean I could put 4 with 2? No. So again, more tricks and helpfulness, knowing that this would have to be 5 and this would be 4. Now we just have to worry about the signs. So I want it to multiply to a negative and add to a negative. So I want 2y times negative 4 be negative 8 plus 5y to get me back to negative 3y. Okay, good job on number 8. Okay, let's look at number 9. 6x squared minus 7x minus 20. Okay. Is there a GCF? No. Okay. But can I automatically say that 6x and x is my option for setting up my binomials? No. So now I've added another layer of guess and check method. And that's because every number we've done so far, if you notice, has been a prime number. 2, 3, 5, 7, 2, 3. All these are prime numbers. The only way to get to that number is to multiply itself by 1. Now I have 6, which 6 could be 1 and 6, or it could be 2 and 3. So it's going to add another layer of guess and check method to your process. And then for 20, again, we have 1 and 20, 2 and 10, 4 and 5. Now the rule still applies that you can't have an even number with another even number, because then that means there should have been GCF to begin with. So right away, that means that 2 and 10 will not work, because either option I pick, either 6 and 1 or 2 and 3, there's going to be an even number, and I can't put an even number with an even number. So I know 2 and 10 won't work. Okay. Okay. Now I also know that I'm not going to most likely going to want 1 and 20. Can't rule it out yet, but most likely I'm not going to want it. Okay, just as evident of all the things we've tried. Now we do need to try 6 and 1 versus 2 and 3. So if I put 6x and x, I just need to test my numbers. So do I want 1 and 20? No, I don't want to multiply 6 times 20. Do I want 20 and 1? Nope, not going to get me what I want. I don't want that one. Okay, what about 4 and 5? If I put 4 and 5 here, that's going to get me 30 and 4. Not going to get me what I want. I'm trying to get to -7. If I try 5 and 4, that gets me 24 and 5. Still not going to get me what I want. So now we notice for the first time that my first terms are not correct. So that means I have to switch my guess and check method to 2x and 3x. Okay, and I realize I crossed off 1 and 20, but it still could work. So do I want to multiply either of these numbers times 20? No. So again, your first option is very rarely your first set of factors is very rarely this factor set you use. So 4 and 5, let's try that. So if I put 4 and 5 here, I get 10 and 12. Will 10 and 12 get me to 7? No, so let's hope the last one does. If not, this doesn't factor. Let's do 5 and 4. 8 and 15. Can 8 and 15 get me to -7? If we have the correct signs, yes. So therefore we would want -15x and +8x to get me my final answer. And again, you can always double check by multiplying back out. Number 10, 10x squared plus 13x minus 30. Not a GCF, so I need to think about my factors. 1 and 10, 2 and 5, 1 and 30, 2 and 15, 3 and 10, 5 and 6. So there are a lot of options on this problem. So it's all about guess and check method, and it's all about reasonable. Okay, we're trying to get to 13. So am I going to want to multiply 10 and 30? Not likely. So normally I always suggest just try your smallest factors. Don't always start with the 1 and 10 or 1 and 30. Start with the lower ones. Start with 2 and 5 and 5 and 6. Because normally when you're trying to get something that's medium or small, you don't want the big numbers. So let's start with the smaller ones. 2x and 5x. And let's try 5 and 6. Now by definition, I can't put 5 with 5, and I can't put 6 with 2, so it means I would have to try 5 and 6. Let's see how that would work. It would give me 12 and 15. Could 12 and 15 get me to 13? Sorry, not 15. Sorry, I like said 15. I'm like, that's not the number I want. Sorry. 12 and 25. Could 12 and 25 get me to 13? Yes, yes, it could. Okay, and just need the correct sign. So +5 and -6. Sorry, my bad. I said 15 and I just kept staring at it like that was fine. And then My brain connected with my mouth and I'm like, nope, that's not the number you wanted. We make mistakes too. Try that again. Okay, so again, it's all about a process of guess and check method. Six n squared minus 18n minus 24. Okay. Remember, first rule of factoring is always GCF. We notice how we have a factor of each of these is 6. So we could take out a factor of 6, and I'm left with n squared minus 3n minus 4. Well, then I just have n squared to work with. That 6 still needs to be there, but now I can resort back to my numbers or work from the previous lesson. So now I'm just worried about factors of 4, negative 4, adding to negative 3. So I get 6 times n plus 1 minus 4. This would be my final answer. Let's try another one. Okay. Hopefully right away you notice that these each have a factor of 5. We take out a factor of 5. Then we're trying to think of factors of 30 that add to 11. And we don't have to consider that first leading term because we took the factor out. So now it's just an a of 1. So 5 and 6 are the ones we want. And they would both have to be negative. Okay, now like I will mention in class, it doesn't matter the order of your binomials. GCF should always be listed first, but as long as your binomial itself is correct, oh, I didn't even write R in this one. As long as your binomial is correct, it's okay. Okay. Back to these ones over here that we were doing, where there's a lot of guess and check. It is very important that they are correct, okay, the binomials themselves. Okay, and we're going to do more of those, just throwing in a couple GCF ones here. Okay, I'm going to go ahead and write out a few of them, and I'm going to have you guess and check, and then we'll talk about them in just a sec. Okay, go ahead and try 13 through 15, and I will pause the video and come right back. Okay, let's see how you did. So on 13, you should have gotten 3x minus 8 and 5x plus 4, or 5x plus 4 and 3x minus 8. On 14, 2b minus 3, 5b minus 6. And 15 had a GCF and factored, so 4x times x minus 24 and x minus 1. There's an option there where we actually used the big number because we wanted to get negative 25, so we had to get negative 24 in there. Okay, so hopefully these are going better for you. If you're having questions, please contact me. Okay. One more here. X squared plus 6xy minus 16y squared. Okay, as you notice, there's two different variables, okay? Meaning we're going to have to incorporate both variables in my binomials. Let's work with the first term, x squared. Okay, well, we know x squared should be split as x and x. Now, for negative 16y squared, obviously I'm going to have to get a y value in there, right? There's going to have to be some kind of y value because I'm multiplying to get xy, so x times y, and then multiplying y times y to get y squared, okay? So that's all that is. I just have a second variable in there, but now I can just focus on my factors. So factors of negative 16, 1 and 16, 2 and 8, 4 and 4, okay? Which ones are going to be added or subtracted together to get 6? So thinking about my signs, I need to multiply to a negative, so one has to be positive, one has to be negative, and we want it to be a positive 6, so therefore, looking at my factors, that means I want x plus 8y, x minus 2y. And let me just show you again how that works with checking. X times x is x squared. X times negative 2y would be negative 2xy. 8y times x would be positive 8xy. And 8y times negative 2y would be negative 16y squared, which again would combine to our original problem. So again, factoring is a self-checking method. You should never get a problem wrong, okay, unless you don't do it, okay, or unless you don't check. Okay, good luck. If you have questions, let me know.